Welcome to section 3.2. Now that we have a sense of the concept of probability and how we can measure things that are uncertain and how we write that in mathematical notation, let's look at how this actually comes up. And it comes up in our work through random variables and probability distributions. So as a quick informal definition, this should suffice for us. A random variable is some variable. So remember we talked about, well, what's a variable in chapter 1? A variable like something you measure, like your sales is a variable, for example. Your sales in 1 week is different from your sales in another week, the number of customers you have. If you've got a band that plays events and restaurants on weekends, the number of gigs you play each week, all those are examples of variables that you might care about in the work you do. So a random variable is a variable whose values come with a certain probability. The probability that the number of customers is 350 this week is 12%, for example. The set of probabilities for each value is the random variable's probability distribution. Now, and we're going to see an example in just a minute, but we don't necessarily have a probability attached to each value. Sometimes we have a probability attached to a range of values. Here's an example. You run some sort of business that has customers. Could be a fast food joint, could be a marijuana dispensary, it could be a hair salon. And you've got a probability, this probability distribution describes the probability that the number of customers you have in a given week will be in one of multiple ranges. So the probability that you'll have between 0 and 100 customers in a week is 10%. From 100 to 200, that's 15%. Notice I'm converting these decimals to percentages, right? 0.10, 0.15, and so on. The probability of having over 500 customers is 5%, 0.05. And I've also made a graph of the probability distribution. You'll see along the x-axis each range of possible customer numbers, and the height of the bars tell you the probability that the number of customers will fall in one of these bins. We can combine these, since none of these bins overlap, we can combine them to figure out probabilities for larger regions. For example, the probability that we will have between 100 and 300 customers, well, we take the 0.15 or the 15%, add it to the 30% and get 45%. The probability that we'll have less than 200, well, that's 0 to 200, so that's 25%. 0.10 plus 0.15, 10% plus 25%. So let's see some of these examples from this probability distribution worked out using probability notation. So reading off the table, we saw that the probability that 100 was less than the number of customers was less than 200 was 15%. That's just given in the table. If we want the probability that the number of customers is less than 200, which implies it's between 0 and 200, well, we take from 0 to 100, which was 10%, add the probability that the number of customers is between 100 and 200, that's 15%, so for a total probability of 25%. We want the probability that the number of customers is between 100 and 300. We take the probability from 100 to 200, which is 15%, and add it to the probability that we have between 200 and 300 customers, which is 30%. The total probability is 45%. Notice that the probability of a number of customers being between 0 and infinite is 100%. You'll have 0 customers, 1 customer, 2 customers. You'll have some number of customers. And although I didn't say less than or equal to, we should include 0 as a possibility. So that's everything, right? So all your probabilities add up to 100%, or they have to, in decimal form, they have to add up to the number 1. Also, just note the probability of any event has to be greater than or equal to 0, which we say in mathematical terms is non-negative. And oops, I didn't close that parenthesis. This fact can be useful in the following way. We can use the probability distribution to add up to find the probability that the number of customers will be bigger than or equal to 300. Well, we take the probability that number of customers is between 300 and 400, that's 20%, add the probability that we're between 400 and 500, another 20%, and finally the probability that we're greater than 500, which is 5%. Add them all up, that probability is 45%. If we want the probability that the number of customers is less than 300, we could add those up, but because the probabilities all have to add up to 100%, and these two events are what we call complements, then we can just subtract the previous probability of 45% from 100% and get 55%. If we were working with decimals, it would be 1 minus 0.45 to get 0.55. We're going to continue with this example and do more with it in the next video.